My name is Antonio Iverdi, and I did the video that is a professor debate about do we live in a simulation for my second public lecture. The main idea behind this public lecture is they talk about the theory behind the simulation hypothesis. So there's a unit called the Planck length, which is the smallest unit of length in our universe, and the space of a Planck length cannot be divided any further. So people theorize that the Planck length can be seen as a pixel, or if we're talking about 3 dimensions, a voxel, as being the smallest unit in our simulation of the universe at some finite resolution, and that finite resolution would be the Planck length. So there's a panel of 6 academics giving their stances on whether we live in a simulation. Some people say yes, some people say no, others say otherwise. And they each take different approaches for giving their evidence as to why they believe this way. One person gives a neurological explanation talking about how the brain perceives reality and the idea of consciousness, so she takes a neurological perspective. A few of the other academics take a mathematical approach behind tackling this question, comparing the speed of the brain versus the speed of a computer in hertz, and just comparing the processing powers between the two entities. And then we also have some computer science explanations, talking about computation. Can certain aspects of life be computed? The reason I was curious about this video is that, especially AI technology becoming more increasingly popular, and even very well-reputed CEOs talking about this possibility, I thought, why don't I actually hear from some, academics who actually want to talk about this topic and not some news article online. One thing I learned initially was the actual theory behind the simulation hypothesis. I didn't know there's an actual scientific explanation for like the Planck length and being the smallest unit of distance, rather than just some celebrity suggesting this and people watching The Matrix. I also learned about how difficult it actually is to simulate something such as water in a tube. One of the academics on the panel mentioned how it could take 2 to 3 grad students and it could take them a long time just to even simulate something as simple as water flowing in a tube. Another thing I learned is that there's no way for a computer to tell the difference between if a program is being run or if the program is being called on. And that could really be a key point in explaining if we're going to be in a simulation, because there's no way for us to know if what we're seeing, if a program is being run on its own or if this is a program that's being called on. So I thought that was a pretty interesting point. And lastly, that every time a memory is recalled, it is altered. I actually didn't think about this too much in depth until one of the panelists described how there's a theory that if you think about a false memory over and over again, you can actually make your brain believe that false memory to be true, and then you can recall that memory as if it actually happened. So if that's the case, that's a pretty significant point in this whole simulation argument. One thing I already knew is that there's no evidence to irrefutably say that we do not live in a simulation. I think this point was brought up when they asked about if it's an empirical question. This I already knew. I personally don't believe we are in one, but there is no evidence to say that we are not in a simulation. Another point that I already knew is that computation refers to a well-defined change of state. So when you think of human life being computed or certain aspects of your life being computed, you would say oh, it definitely can't be. But it just refers to a well-defined change of state. And in a lot of aspects in our life, we see ourselves in a very well-defined change of state. So my curiosity is that, and from the video, is that a large majority of the audience voted in the poll that they do believe they're in a simulation. I thought this was very surprising and piqued my interest, because I thought many people would have said no. Also, one of the panelists described how he believes we're in a simulation because of the way information is mediated in today's world. For example, what we hear on the news, it's almost like the information that is given to us to perceive is kind of picked out for us. So it's almost like what we're seeing on the news and how we perceive the world is simulated in a way. And lastly, someone also made a point about how this theory came up because of the available technology we have. We are conditioned by our available technology. So, in the past, we never even thought about if a simulation was a possibility because we didn't have this AI technology popping up. Now that we see AI becoming more prevalent and of higher interest, then this theory has somehow came up. So I think that whatever technology is available conditions what we wonder about. And I never thought about things like that. In terms of what I study, I'm doing industrial engineering, so we do lots of simulations of queuing systems and assembly lines, and even a simple scenario of a simple ticketing queue takes a lot of considerations and can be pretty complex. So it was interesting to me to hear that even something even simpler, I mean, on a physics scale, like for example, simulating water in a tube is far more complex. And if such simple scenarios are so difficult for us to simulate, I think the idea of our whole universe being simulated is very far-fetched. However, if we can find a way to simulate things on a more complex scale, that'd be very useful for the major of industrial engineering. And lastly, in terms of following up, it took me a while to wrap my head around the Planck length theory, so I had to look up further and in a more concise way explain how a Planck length could be considered one pixel of our universe. I didn't actually know what a Planck length was, so I had to look it up more. And then I was just curious as I was reading through other articles, like how many dimensions would we need to actually simulate our universe? And I thought it'd be a lot more complicated than 3 dimensions, but in terms of simulating a real world, we would only need 3. Obviously, we can't use 2 because we don't see things in 2-dimensional space, but we also wouldn't want to use 4 dimensions. I just thought that was pretty interesting.